In this lesson, we are going to have a look at bearings and its application in relation to navigation, with a specific focus on dealing with non-right angled triangles. Now, let me just remind you here, when we learned about non-right angled triangles, the two rules that we really emphasized on to find missing lengths and missing angles is the sine rule and the cosine rule. So that's what we will have to use in this particular chapter to find any missing lengths or angles. Right, now bearings, right, obviously the focus of bearings is the true bearing. So just doing a quick revisit, right, true bearings are always measured from the north direction. It's always measured in the clockwise direction, right, so which means the 0 degrees is over there. That's my 90 degrees. That's 180, 270 here, and then one complete revolution takes us to 360 degrees, right? So that's just a quick refresh on what true bearings is all about. All right, so let's jump straight into this example. So a yacht sails on a bearing of 38 degrees T for 3,000 meters. It then alters its course to a bearing of 318 degrees T, true bearing, and after sailing for 3,300 meters, it reaches its final destination. Right, so there's two parts to this journey. The first journey is 3,000 meters at 38 degrees T, and the second journey is on a bearing of 318 degrees T for a distance of 3,300 meters. Right, so the first part is obviously we have to draw a diagram to illustrate this situation. Now, one of the things I like doing before actually drawing my proper diagram is to actually quickly see which way the ship's basically turning, just to make sure that I can place my diagram in the right format so it's actually looking nice and clear. Right. So the first part of the journey is 38 degrees T, so which means it is going to be somewhere in that direction there. So that's going to be the first part of the journey. Right, and the second part of the journey is on a bearing of 318 degrees T, so somewhere in that direction. So that's going to be my second part of the journey. So first, they're obviously in two different directions. So going left first, followed by going right first, followed by going left. Right, so that's the first part and the second part of the journey. Right, so what I'm going to do here is obviously I've been given the space to draw this diagram. Right, so because I'm going to go right first, followed by left, I'm going to start my diagram on the bottom section of this page. So the first part obviously is to draw my true bearings, or a compass, right, just to represent my north direction. And the first part of the journey is on a 38 degrees true bearing for 3,000 meters. So I'm just going to draw that in this diagram here. Right, so 38 degrees measured from the north. Right, and let's say we start at position A, right, and we reach a position B in this diagram, right, and that distance that we've traveled is 3,000 meters, right. From here onwards, the boat then travels for 3,300 meters on a bearing of 318 degrees true bearing. So we will have to draw another compass here, right. So obviously that's my north direction, so 318 degrees T. So 0, 90, 180, 270, 270 plus 48 is going to get me to 318 degrees T. So which means the boat's going to travel, it's roughly somewhere there, for a distance of 3,300 meters. Right? Now obviously, as you can see, intentionally I've made this line longer than the previous one, just because the distance we're traveling here is 3,300 meters, right? The more we represent that kind of information, the better looking our diagram is, or in other words, more accurate our diagram is. Now in terms of marking some angles, right, so 318 degrees T, that's what we're traveling on. So 0, 90, 180, 270, 270 plus 48 gets me to 318 degrees T. So the angle I'm going to mark there is basically the 48 degree angle, right? Now here's another hint I want to tell you, right? When we are dealing with bearings and dealing with non-right angle triangles, The first and the most important thing we're going to try and achieve is to try to get an angle inside the triangle, right? So obviously we can see that we have a triangle formation between A, B, and C, right? And that's why marking these angles is going to be so much more critical. Right, so that is 48 degrees there, right? And you know, looking into alternate angles, right? So if this angle is 38 degrees, right? This angle here must also be 38 degrees. Right, and 90 minus 38, 90 minus 38 is going to give me that this angle here is equal to 52 degrees, right? Which also now gives me that this total angle inside this triangle, or angle B, is 48 plus 52 equals a 100 degree angle, right? And I'm just going to complete my triangle. So this part of the question is just to complete my journey, which we've already done. Right, moving on to part B. The question is saying how far is it from the starting point correct to the nearest meter. So obviously the question is basically asking us to find the direct distance from where we started and where we finished. Right, and that's why we have the complete triangle now, A, B, and C. Now if I look at this triangle, I'm just going to draw a rough diagram on this side here just so we can make some sense out of it. Right. So I've got my 3,000 meters there, not bad, 3,300 meters there, and I have my angle in between as 100 degrees. So we got two sides and an angle included, and the included angle, right, which takes me to the hint of using my cosine rule to find the direct distance between points A and C. Right, so we're going to use the cosine rule to work out this missing length. So if I write down my cosine rule for this missing length, I'm going to have x squared equals 3,000 squared plus 3,300 squared minus 2 times 3,000 times 3,300 times by the cos of the angle in between, right? So we get the answer for that, and if we take the square root of the answer, that should give us the final answer. So I'm going to use my calculator here. (3,000 squared plus 3,300 squared minus 2 times 3,000 times 3,300 times cos 100. I'm just making sure my calculator is in degrees. Right, so that's the answer for x squared. Right, so in order to find the answer for x, I'm going to square root this answer. So it gives me the direct distance between points A and C is 4,829.93. So 4,829.93 meters, right? Obviously the question wants us to round the answer to the nearest meter, so the nearest meter is going to be 4,830 meters is how far the yard is from its starting position, right? So if I go back into this diagram here, so answering part A, we have now worked out the direct distance between points A and C. So 4,830 meters is the distance between the yard from its starting position. All right, now moving on to the second part of this question. All right, what bearing should it travel on to reach the starting position? Round your answer to the nearest degree. Right, so the bearing question is often the most challenging part of this of this topic. So I'm going to go back to this, go back to my original diagrams. The question is basically asking what bearing should we travel so that we can go back to the starting position. So at the moment my ship is at point C. So I'm going to draw my compass there, right? And this is where representing the lengths more accurately is going to be so much more significant, right? So if I want to travel back to a starting position, right, the bearing that we need to travel is going to measure that much, right? That's going to be just shy of 180 degrees that we can see, right? So that's the bearing we need to travel in order to get back to the starting position, right? Now, in order to work out the bearing, get back to the starting position. I'm going to quickly go a bit more deeper into this diagram. Now, when we're dealing with compasses, alternate angles are really critical. So if I quickly zoom into this diagram a little bit further, I can quickly see that this 48-degree angle here alternates with this angle here. So what I'm talking about is, I'm talking about this angle here. I'm just going to extend that. This angle here is alternate to this 48-degree angle, so that must be equal. And this first part of the bearing, obviously that is 90 degrees, right? So in order to work out the bearing that we need to travel back, right, all I need to now work out is I need to work out this missing angle here. So if I find out this missing angle, 90 plus 48 plus the missing angle should give me the bearing that the ship needs to travel so it can actually go back to its starting position. Right, so in order to work out this missing angle, right, so obviously we have all the three sides now. We have a pair of an angle and a side as well, so we can basically use any combination. We can use the cosine rule or the sine rule. It doesn't really matter here, right? So just for a change, I'm going to use the sine rule to work out this missing angle. All right, so if I use the sine rule to work out this missing angle, so I'm going to have sine theta. I'm just going to do my working out here. Sine theta over 3000, that is the side opposite to theta, equals sine 100, and the side opposite to that, which we've just worked out, is 4,830 meters, correct to the nearest meter, right? So now in order to solve for sine theta, we've got to first multiply both sides by 3000 and then do the sine inverse. So I'm just going to represent all of that in one step. So sine 100 over 4,830 times 3,000, all right, and just that's what we're going to put into our calculators. $4,830 times 3,000 gives me the value for theta. Now 37.7 degrees, so theta equals 37.7 degrees. All right, so which means the bearing that we need to travel, right? So which is, the question wanted us to round it to the nearest degree, so this is going to round up to 38 degrees, right? So if I quickly go back to this working out, I can see that the bearing we need to travel is going to be equal to bearing of point A from C is simply going to be equal to 90 plus 48 plus the 38 degrees which we've just worked out, right? And that is going to be equal to, so 90 plus 48 plus 38 gives us a total bearing of 176 degrees T that the ship needs to travel so it can reach point A back again. So that's the bearing it needs to directly travel in order to reach point A again. So again, like I said, the key part of this question, right, is to be able to draw your diagram as clear as possible, right? And the second key part is to be able to work out an angle inside the triangle. And once you work out an angle inside the triangle, everything else kind of follows itself, all right? Beautiful. Thank you for listening, guys, and have a wonderful day.